Today we're going to take a look at something very unusual, a Commodore that worked when I first got it. So I'm happy to show this one off today because there's no ICs to go bad in something that's electromechanical. Longtime viewers will know I have a firm rule about not buying adding machines, and hey, no, don't judge me. We need that later. For now, we're looking at this. The reason I tend to avoid these is that they're all fairly similar. We have an addition total button here, a sum minus button here, an NA button, I don't remember what that does quite exactly, and a repetition button which doubles as multiplication. The Commodore badge here though is what makes this one interesting, because it's what Commodore was doing before they entered the home computer market. Commodore had made a few things before they ended up in home computing. They made typewriters and calculators like this one. Now they didn't always make everything that has their name on it though. Another Commodore calculator is actually a Casio 121, and the Commodore 208 here is actually a Ricoh. A lot of early calculators came from Japanese companies, so it doesn't really surprise me too much to see made in Japan on here. Now, it's not a put down on the Commodore here because it was very common for foreign companies to partner with domestic ones to put a local name on a product so it would sell better. But that's enough history for now. I'm going to keep this video simple like this calculator itself is. And again, that's not an insult. A simple calculator is great for simple jobs. So let's get this thing turned on. And, well, yeah, that's pretty much it. It's on right now. For electromechanical devices like this, once you have it plugged in, it's really always on. There'll be a mechanism inside that controls power only when you need to perform actions. So if we do something like clear the register, the motor will activate and then immediately shut off. The 208 here is in fact a 10-key calculator, which means you don't have to press a grid of keys to operate it. But that's not the whole story, as we'll see inside. Mostly mechanical calculators like this typically have two registers, one for the input and one for the total. You likely saw the white bar here move across the digits there as I was typing on the keypad. This shows where you are on the input register. In order to see the total register, you need to add to it. This displays the current value of the register up here and clears the input register. Now, the two registers on this calculator are what I would consider to be non-visible, because as you type your number into the input register, you don't really know what it is. You can clear it and then reset it if you think you made a mistake, but you can't actually know what the value is. And I'll admit that's only partially true for the total up here because you can print it at any time. If I put 5 into the total register, I can use the subtraction key to print out a sum of the value, which can then be reprinted at any time. Pressing the T key, which doubles as the addition key, will total the result, which then clears it out. So if I try to print the total again, we'll find that it's empty. And as I've been messing around with this, I figured out what the NA key means. It is non-add. So if I want to put a number just on the paper, I can press the NA key, and it will print it with an N, indicating that it was not added, and then the actual total is not affected. Now, the sum/subtraction key down here is red for a reason. Let's say we have 10 as our total value, and then we want to subtract 5. The subtracted value is printed in red, which is pretty sweet if you ask me, and something you don't get with a digital calculator. Now, if we print our sum again, we're going to see that we have 5s. But if we do a 6 subtraction, we will have now underflowed the total register. And if we print that now, we'll see that we have a -1 as our sum. How weird is that? This thing actually understands negatives. We can also total this, and we have our final value of -1. I find that to be unbelievably impressive for something like this. Now, it does leave it in a slightly quirky, weird state where if I press the total key again, it prints the total as -0, which isn't quite right. But I'm still going to give it an applause because properly handling negatives and underflowing on a mechanical calculator is quite cool. Now around back, if we take out the paper spool, we can actually see that this has directions built in that tells you how to change the ribbon. But there's something weird about this, and we're going to have to open it to really see that. On the bottom, there are two latches here that just need to be slid towards the front of the calculator to be able to lift the body off of the metal construction. So if I flip it back over now, it lifts right off. And here is where my problem lies. Now, if we look at those directions a little closer on the back, you'll see that it tells you exactly how to route the ribbon with a graphic. Well, mine here is not routed correctly, and there's a good reason for that. These are not the original Commodore spools that go on this calculator. These are. Now, there are a couple of reasons that you have to use these spools instead of something like this that I'll get into in a moment, but unfortunately, I couldn't, at least not today, because some person was a little overzealous with their oiling of this calculator, and this thing is completely saturated with oil, and it no longer leaves the ink down when you try and type with it. As I unspooled this when I was trying to check this, I actually found there was some dry area towards the center of the ribbon where it became obvious that it was really soaked, and yeah, we can start to see the blurring between the two lines there. So this ribbon does not work anymore, which is a shame because these are intended to go back and forth and be used a lot. But that one's dead, so I would need to get a new ribbon. Well, this ribbon's weird. Let me take this one off and show you. This one is a more standard adding machine ribbon. We have some little clips there that grasp onto the spool pin, and then pegs that go into the driving gears that rotate the ribbon. The Commodore ones, though, have this weird hinged clip thing that holds them on, and then a single tab that pokes up that is supposed to be caught. But that's not the problem. The problem is this is the drive side and this is the drive side, but the ribbons are backwards. Now, it might be possible to take one like this and completely unspool it and then spool it the other direction to make it work. But the other problem is the latch piece doesn't really work, and the ribbon spool can walk back and forth while it's on the calculator, which messes up the belt routing. And on this one, I've been having it fold over on itself and get wrinkled, so it's kind of been a problem already. The only reason I even had that ribbon is because I have this Olympia adding machine, which is a slightly, I assume later, I don't actually know what year this is from, but later model, and it uses the gears with the holes cut in them so that the tabs on there can align, and this is a bit more common. I pretty obviously got the Commodore adding machine because it's a Commodore. The reason I got the Olympia is, man, it's pretty. But this video isn't about that one. Now, I have been somewhat able to get this ribbon to work by incorrectly routing it with red on the inside, and then trying to get the 3 tabs to line up with the 1 tab location on the Commodore, and it mostly works, but this is definitely not the correct way to set this up, and I keep having this issue here where the ribbon folds over itself, like I mentioned, so I don't think this could be used long-term. So unfortunately, these aren't going to be easy to maintain going forward. Man, my fingers keep getting disgusting from this. Now that I've gone and routed that ribbon, I'm actually going to go ahead and remove it because I want to run through a couple of things mechanically with this to show you because it's pretty interesting and I don't need to be putting a bunch of ribbon onto the platen. First off, I mentioned that there would be an electric switch to run the motor, and I believe that is this because every action, like total, clear, sum total, non-add, and multiply all run that switch, which seems to be connected near the power plug. Another thing in here is this red tab, and this is kind of weird. I don't fully understand why this exists, but I do understand what it does, because if I push it in and then pull it back and slide it into the other side, it locks the keys for the input register. We can actually see how this is doing this too. With the lighting and angle just right, you can see I can wiggle that tab at the end of the piece of metal there. That tab is towards the end of the input register piece. What you do is you push it in and put it behind that and then pull it over so that this is hooked in back here and can't move forward. Then when you press a key, it literally cannot physically move the input area forward and it's locked in place. This might have been a shipping thing, I'm not sure, because you can't access this lever from the outside, but it's a weird thing to know about. If it seems like your keys aren't working, you may just need to move this lever over. Now there's something else interesting to see in this area by the input. If I type in 1, 2, 3, 4, 5, 6, 7, 8, that becomes available. You know what that looks like to me? A grid. A grid like this. 1, 2, 3, 4, 5, 6, 7, 8. The same principle that a calculator like this operates with is still basically how this one operates. There is a grid internally that is used to hold all of the values for the input register. This one just hides it in a clever way. Due to just how dense this thing is, it's a little difficult to see, but those horizontal black bars are connected to all of the keys. So if I wiggle 9, you can see it's at the top. 8 right below that, 7 below that, 6, 5, 4, and then 3, 2, and 1 are at the bottom. Every time you press one of the keys, it presses one of the pins in the grid in, and then the grid advances by 1 space. So you enter all of the keys just like you would on a grid calculator, but it cheats by moving the grid over so you only have 1 row to input at a time. I love figuring out how these calculators store data like this, because that metal grid is your RAM. That is how numbers are put into memory on this thing. So it's just really cool to see that in action to me. Now, as I've been working on this, I've been trying to figure out how the total register works. I can see some stuff going on in there, but not really enough that makes it easy to figure it out. So I'm not quite sure how that one works. If I would have to guess though, I would say it's possibly like a pinwheel calculator where there's a rotating drum that has slides that hold the value, and the slides are moved by the positioning of the pins on the grid. That's how the Bond Context 10 mechanical 10 key I reviewed a while ago worked. Now, while I have this open and I can have a little bit of fun here, I'll mention that this calculator does not have a concept of division. So the questions that I always get asked on these videos of what happens when you divide by 0? The answer is you cannot divide by 10 on this one. And unlike a lot of calculators where I can usually trick them into doing division some way, this one would be a little more difficult with the 10 key input to the blind registers like this, so I'm not going to attempt it here. But if I could, there are really only 2 possible outcomes on a mostly mechanical calculator like this. Either it would be like this, it's always dividing by 0, or it would be like this, constantly running because it never reaches an end state. Now, we're pretty close to wrapping this up on here, but I want to show some of the cool tricks this has with the original spools, because this is annoying that they're different, but it's also pretty clever. This is the retention lever that I was mentioning, and when you pull it down, it should slide into a groove on the pin that holds the wheel on, and yeah, that just guarantees that it cannot fall out. So that's kind of cool and very positively mechanical. The last thing I want to mention in here is this unusual lever, and it's at least unusual to me. I don't know if this is common, but none of my other printing calculators have this. This tab rests on the fabric of the spool inside, and that depth keeps this latch from going farther up. If I flip this around to the other side that has the empty spool on it, you can see that reaches much farther up. I believe this is supposed to interact with this, which pushes a gear that rotates the ribbon. I'm honestly not 100% sure how this works or if it's working correctly on this unit, because sometimes it advances ribbon and sometimes it doesn't. I'm finding that part to be very confusing to figure out, but when I get it working, it seems to work fine, so I don't know. But not really with this ribbon, because again, that one's hosed from getting oil in it. And I think that wraps it up for the Commodore 208 from the late 60s. This is a fairly good looking calculator too. I didn't really mention that earlier. I quite like the design with the accent colors. There is also a horrible looking beige version of this, and that one is nowhere near as cool. This one definitely is the better looking one. Well, I hope you guys enjoyed this look at the Commodore 208. These calculator videos usually aren't the most popular ones on my channel, but I do enjoy making them. If you want to help support the channel, you can find me on Patreon, but for now, that's it, and I will see you next time.